Today we're going to talk about something called a two-proportion Z interval. So if we take a look at this problem, it's about young adults that still live in their parents' homes. And a survey was done in which 2,253 men were interviewed, and of them, 997 of the men said they still live in their parents' house. And then in addition, 2,529 women were also interviewed, and 899 of them said they still live with their parents. So one thing I like to do right away is calculate your sample proportions. So I'm going to let p hat sub m be the proportion of men in this study that still live with their parents. And to do that, you take the 997 men who said yes and divide by 2,253. So if we do that, 997 divided by 2,253, we get a proportion of about 44%. If we do the same thing for the women, let's color code this. So in green, p hat, the proportion of women in the sample who said they still live with their parents, we had 899 divided by 2,529. So let's see what that proportion is. 899 divided by 2,529. And in that case, we get about 0.355. Okay, so it looks like this smaller proportion of women, I should say young adult women who are still living in their parents' house than there are men who are still living in their parents' house. So we're going to do a little better than that today. We're going to do what's known as find a confidence interval. So construct and interpret a 99% confidence interval for the difference in the true proportions of women and men living who still live in their parents' homes. Okay, so there's no HO and HA in a situation like this. You go straight to your assumptions. So let's do that. Number one, both should have been random samples. Both are SRSs. Number two, we need to check that the population of all men is greater than or equal to 10 times the sample size in our sample, in our study that is, and that would be 10 times 2253 or 22,530. Well, there's definitely more than that many men in the world that could have been surveyed. Since this is true, that tells us that the standard deviation of p hat for the men is the square root p hat for the men times 1 minus p hat for the men over the sample size of the number of men. So we can actually plug these numbers in. So it'll be the square root of 0.44. We're getting that up here. Times 1 minus 0.44, which would be 0.56, over the sample size in this study, which is 2253. So let's take a minute to type that into our calculator. And I'm getting around 0.0105. Okay. We have a second assumption to check. We also need to check that the population of women is greater than or equal to 10 times the sample size of the number of women, which in this case was, if we look here, 2529. 2529, which is 25,290. Well, there's definitely more women than that in the world. And since that's true, we can say that the standard deviation of p hat for the women equals the square root p hat for the women times 1 minus p hat for the women over the number of women sampled, which in our case would be the square root of, and if we look up here and remember, our proportion, our p hat for women was 0.355. So I'm going to say 0.355 times 1 minus 0.355, which will give you 0.645. And we had to divide by the sample size, which you said was 2529. So if we type this into our calculator, 0.355 times 0.645 divided by 2529, and then we take the square root of that, we end up getting a standard deviation of around 0.0095. Okay, great. Finally, we need to check for normality. So let's go do that. So we're going to check for normality. Then we need to check four things. One, the number of men in the sample times p hat of the number of men who said they still live with their families, and the number of men in the sample times 1 minus p hat for the males. Both of these need to be greater than or equal to 10. So in our case, in case we forgot, the number of men were 20 to 53. You can see that here. Let's use a different color so you can see it where I'm underlining in red. And then the p hat for the men was 0.44. Okay, so if we take the time to type that in, we will get, I just forgot it again, 2253 and 0.44. 2253 times 0.44, and you're going to get 997. And so then when you do 2253 times 1 minus 0.44 or 0.56, you will get the other men that didn't say yes, they're still living with their parents. So that's this number. Either way, they both greater equal to 10, so that's a good start. We now need to do the same thing for the women. And for women, times p hat women is 2529 times 0.355, which ends up equaling 899. And then you have n for the women times 1 minus p hat for the women, which is 2529 times 0.645. So 2529 minus 899, and we get 1630. So here you are. These are both great. All these things are greater equal to 10. So that tells us that the distribution of p hat men minus p hat women is approximately normal. Okay, so in really good shape now. We're ready to build our confidence interval. So the confidence interval looks like this. You have to pick an order. So we're going to do p hat men minus p hat women plus or minus z star times the square root of p hat men times 1 minus p hat men over n men plus p hat women times 1 minus p hat women over n women. So this is the basic format. Now, a couple of things you should notice. We found earlier in the problem the standard deviation of p hat men. And we did that by finding the square root of p hat men times 1 minus p hat men over n men. And if you look at this here, what that really is, it's that standard deviation we found, but squared. And that's why you don't even see it, because standard deviation squared goes away. So if I just get rid of those things, this is really here a variance. And that's a good thing, because we said you can only add variances. And similarly, this thing here is the variance of p hat women. That's what that is. So that's where this formula is coming from. You're really adding here, you're adding this variance and this variance together, and then taking the square root to make it a standard deviation. So let's actually do our work and find the answer here. So this is going to be 0.44 minus 0.355 plus or minus, we'll leave z star blank for now. And this is going to be the square root of our two standard deviations squared. So just to remind you, the standard deviation for the men was this 0.0105, and for the women was 0.0095. So when I put that in here, I'm going to do 0.0105 squared, because you can only add variances. 0.0095 squared. So I took those standard deviations, I made them back into variances. Okay, and then finally I need the z-star that goes there. Problem did ask for a 99% confidence interval. So we draw a little normal distribution. We put 99 in the middle. And we just need to get the area in this tail. Well, that's 1 minus 0.99 over 2, which is 0.005. And you need to figure out the z-score that goes here. So if you look in a z-chart or you use inverse norm on a TI-89, inverse norm will give you negative 2.576. So we just put positive 2.576 in here. Doesn't really matter. If you put the negative there, there's a plus or minus in front of it, so you'll still get both answers. Okay, so finally, we're ready to compute this confidence interval. So our 99% confidence interval is 0.44 minus 0.3355, which is 0.085 plus or minus 2.576 times whatever that whole thing is. Let me type that into the calculator for you. You will get about 0.0142. So let's actually compute both parts of this interval. And we'll get for an upper bound, so here we are, our final answer here. We're going to get about 0.1215. And our lower bound is, get ready for this, 0.0485. So I'm not going to write it, but we should be able to interpret this. We are 99% confident that the true mean difference in the proportion of men and the proportion of women that live in their parents' homes is somewhere between 0.0485 and 0.1215. I think it's important to notice here that this interval does not contain, or I'll say have, 0 in it. So since it doesn't have 0 in it, that leads me to believe that the true difference in proportions, P of men minus P of women, does not equal 0. Since the interval doesn't capture it, the interval is letting us know that, hey, we think the real difference in proportions is somewhere between these two numbers. 0 is not one of those numbers. So this difference is not 0, which means that the proportion of men who live at home with their parents is different from the proportion of women who live at home with their parents. Okay, thanks for watching.